Okay, this is a continuation. In order to do this part, you're definitely going to need to have all of this done so we can move on. So far we have metals, nonmetals, metalloids, and you guys, aluminum is a metal, even though it's a soft metal. So metalloids, we have noble gas, which is also a nonmetal. Gases are nonmetals. We have protons, electrons, neutrons, positive, negative, neutral. Inside nucleus, outside the nucleus, inside the nucleus. And remember, protons are the ID. We put our model of the atom up here with protons and neutrons in the center. Remember, protons and neutrons is the mass. Also remember, on the first ring, you can only have 2 electrons, second ring, 8 electrons. And honestly, we probably won't go past the second ring, but the third one, anyway, it's still 18. And at the bottom, you should have your reactivity scale for the craziest ones here and the most calm or stable ones here. This is how they react with water, with this being the craziest one. Now let's continue. Oh, and your formulas in the center. The atomic number is the same as the protons, same as the electrons. This and this is the same, if you didn't notice. And your mass minus the atomic number equals neutrons. To find the neutrons, that's the only one you do a little bit of math for. And when I say little bit, it's just a little subtraction. So now we're going to go over groups and periods. So groups are these, going up and down. Those are groups. And if you notice, I did skip the center because in the 8th grade we don't deal with transition metals too much. So these are called transition metals. We don't deal with them too much, but when you get into 10th grade, actually you will. So these are called groups. So let's put our notes. Groups go down. So I made a little arrow to show that groups go down. And this is how we number our groups. This one is group 1. This one is group 2. So we're going to put 1, 2, and then we skip the transition metals. Group 3, group 4, group 5, group 6, group 7, and group 8. So why are they numbered like that? Remember this Bohr's model? Valence electrons are the electrons on the last ring. So every element in group 1 has 1 valence electron. That's a V and an E. Everyone in group 2 has 2 valence electrons. You see where this is going? Group 3 has 3 valence electrons. All the ones in group 4, you see what we're doing here? 5 valence electrons, 6 valence electrons, 7 valence electrons, and all of these have 8 valence electrons. Now, on the 8 valence electrons, this is the most valence electrons that an element can have. So, since this is the most electrons that an element can have, guess what? They're all happy. This guy right here, this is why they're stable and calm, because they have all their valence electrons. So let's put 8 valence electrons on the happy guy. 1, 2, 3, 4, 5, 6, 7, 8. The reason why he's happy is because he's stable. He has everything he needs. Now what about this guy here? So on this end, they all have 1. Atoms bounce around looking for more electrons, looking for more valence electrons. So this guy is crazy because he only has 1. He does not have everything he needs. So we're going to put 1 valence electron on his head. So that's an easy way to remember. All of these have 1, all of these have 2, and so on. So the stable ones have all they need. They have all 8 valence electrons. So that's groups. Groups equals valence electrons. Now let's move on to periods. So this way, all of these have the same rings, energy rings or shells, whatever you want to call them. So let's write this sideways. So periods equals energy rings, shells. So if you're drawing a model, you're going to definitely need this and you're going to definitely need that. So all of these, we're going to go all the way across, have 1 ring. They have 1. So we're going to put 1 ring. All of these have 2 rings. So guess what? We're going to put 2 rings. Your model is going to look like that. All of these have 3. So you're going to put 1, 2, 3. And all of these have 4. 1, 2, 3, 4, and so on. So I'm not going to finish drawing the rings because I can't fit them. But just remember that all of these have 1 ring, all of these have 2 rings, all of these have 3 rings, and so on. So your periods are your energy rings or shells. Your groups are your valence electrons, and you already know how to put in the protons, neutrons, and electrons. So this is actually a completed periodic table, which is good for the STAR test. After the break, we have more stuff to add, but this right here on the STAR test, you guys, this is most of your answers. You're not going to believe it. So let's practice.